We're going to talk about analyzing earthquake data, and I'm putting your notes on Canvas so that you can always refer back to them, and that way if you lose your papers or whatever, you don't have to worry about it. So first thing we're going to talk about is wave motion. A wave is just a disturbance that moves energy from one place to another. So there's lots of different types of waves. Mechanical waves are what we're looking at as far as earthquake waves. They move energy by disturbing or disrupting the matter that makes up objects or substances. So basically, they transfer the energy by causing the building to move or causing the bridge to fall or the road to be disrupted. They affect the matter itself that is made up or that makes up an object. So if the matter moves, it doesn't actually travel. So it just kind of shakes in its spot. It doesn't move from one place to another. The energy of earthquake waves travel from the focus, so this is one of your vocab words, through the earth in all directions. So the focus is where the energy starts. The waves travel both toward the core and the surface of the earth. So the focus is kind of in the middle of the earth, and the earthquake waves, when an earthquake happens, travel in both directions. So they travel towards the middle as well as towards the outer surface. Earthquake waves at the surface cause the ground to vibrate. So the surface waves, so we talked about earlier, a couple class periods ago, how there were three types of waves: P waves, S waves, and surface waves. We've talked about P waves, push and pull. We've talked about S waves, side to side. Surface waves are the last ones that we need to talk about. And they just kind of cause the ground to vibrate. They happen right along the surface, or right actually below the surface of the earth. So as I was saying, here's your different type of waves. Seismic waves are earthquake waves. So then there's two sections of seismic waves, or two different types. You have body waves, which are made up of primary and secondary waves. And then you have surface waves, which there's actually two subgroups of surface waves called the Love waves and Rayleigh waves. We won't really talk too much about the types of surface waves, but just know that there are two subtypes of surface waves. So P waves, we've talked about these a lot. You did these with your spring lab. So P waves are called primary waves. They are compressional waves. They go in a parallel direction to the wave motion. So if this is the way that the wave is moving, this is a P wave. It's going in the same direction. They are also faster than S waves. So if for some reason on your lab you did not get that correct data, if for some reason maybe you put a little bit more effort into an S wave causing it to be faster, because remember, when we're testing variables, we have to make sure we're only testing one variable. So your force for both P waves and S waves should have been the same in order to make the data correct. So P waves are faster than S waves. Not a whole lot faster, but they are faster. So they should reach the seismic station first. S waves are secondary waves, so they're called secondary because they're the second ones to get to the seismic station. They're slower than P waves. They are body waves, and they vibrate perpendicular to the direction of the wave motion. So once again, if this first arrow is our wave motion, this is the way the seismic or secondary waves are moving at this point. They're moving the opposite direction, so perpendicular to the wave motion. Okay, surface waves. So they travel either on the Earth's surface or just directly below it. They are the slowest waves, so they're slower than both P waves and S waves. Some can produce kind of a rolling motion, causing the damage that you've seen. Like I showed a video on our first day of earthquakes where you saw the road all torn up. That would have been caused by a surface wave. So the rolling up and down motion caused the road to disintegrate, basically. They can move material from side to side, just kind of depending on how the objects are built as well as how that particular wave is moving in that spot. And they can cause buildings to separate from their foundations because they are so close to the surface. Okay, so ground motion. P waves go vertical, so they go up and down. I know in our lab we did them laying on the floor, but if correctly, we should have had the spring go up and down for you to actually kind of see how it works. but because those springs are so fragile, that's not really possible. And then S waves go side to side, so we did that one correctly. They go horizontal, shaking at the point of contact. So these are some pictures of what an S wave or a P wave would look like. So pretend that these are the focuses or the foci down here at the bottom. The P wave is going vertical, it's going up and down. So this is your surface, this is inside of the earth. An S wave is going side to side. So once again, this is the focus and this is the earth's surface going side to side. And then a surface wave. So they kind of go side to side and they also kind of roll a little bit. There's a whole lot going on. These can cause quite a bit of destruction because they're so close to all the surface and all of the objects, as well as the way that they move. They can cause quite a bit of destruction. Okay, so recording vibrations. So this is kind of the next section that we're going to look at, is how this earthquake data is even collected. So seismic waves or earthquake waves lose their energy as they travel from the source or the focus of the earthquake up towards the surface and then down towards the core. Seismometers are what are used to detect the vibrations of an earthquake, so to detect that movement or that motion. A seismometer is connected to a system called a seismograph. The seismograph itself is what produces that recording, and I'll show you a picture of one in just a little bit. The locations where the seismometers and seismographs are located is called a seismic station. So I told you guys that a seismic station is where all this data is collected. So that's where these seismometers and seismographs are held. The specific data sheet that is made by a seismograph is called a seismogram. Okay, so this is a sample seismograph. This right here is actually our seismogram. So this is where your data is going to be recorded. But the overall object is a seismograph. So it's what is doing the recording. So reading a seismogram, you are going to do a lab where you look at some data and talk about how you see initially in this particular one, you see the P wave comes first. Then you see the S wave causes a lot more movement or destruction. Each of these in this particular picture are minute marks, and you can see that it started at 8:58, so this would be 8:59, this would be 9 o'clock, so on and so forth. So this shows your P waves are kind of small on your seismogram. They're up and down movements because they do go up and down. However, it looks like the S waves are also up and down movements, but they cause a lot more movement. So they're a lot joltier. And that's because they're moving side to side. Okay, so the last section that we're going to talk about is locating the epicenter of an earthquake, and this is the last kind of mini lab that you're going to do for earthquakes. So the epicenter is located within the earth, or it's actually on the top of it's on the surface of the earth, directly above where the focus was. The focus is what's located inside of the earth, where the earthquake actually starts. If the focus is located more towards the surface, those are going to be the more destructive earthquakes. If it's located more towards the core of the earth, those are going to be less destructive, so they're going to cause less damage. The point on the earth's surface, so directly above the focus, is called your epicenter. That is where the earthquake waves are going to be the strongest. And scientists use a specific graph to kind of calculate where the earthquake started, where the epicenter is, based on the data from their seismic stations. We are going to do something similar to that so that you guys can practice figuring out where the earthquake started. So if this is the focus here, so it's inside of the earth, your epicenter is the portion directly above it on the surface of your earth. Okay. Post your comments or questions below the video if you have any questions regarding this video, and I hope this helps answer any questions that you might have.